In this video, we will use the z-test for one population mean to compare the mean of a sample data to a population or hypothesized mean using a 5-step hypothesis testing procedure. Let's consider the following hypothetical scenario through a case study. A sleep research center claims that adults in a certain city sleep an average of 7 hours per night. However, a local coffee shop owner believes that their customers, who consume more coffee than the average person in the city, sleep less than the claimed average. To investigate this, the owner collects data on the nightly sleep duration of 50 randomly selected customers. The sample mean sleep duration is found to be 6.5 hours with a known population standard deviation of 1.2 hours. Let's walk through a 5-step hypothesis testing procedure, calculating everything manually. The coffee shop owner believes their customers sleep less than the city average of 7 hours. This forms our alternative hypothesis, as it includes an inequality. The null hypothesis will be the opposite, that customers sleep the same or more than the city average. To ensure the validity of the one-sample z-test, we need to verify a few key assumptions: random sampling, independent observations, a known population standard deviation, and a sufficiently large sample size, typically 30 or more. In our case, the coffee shop owner used random sampling. We can reasonably assume the sleep durations are independent, the population standard deviation is known, and the sample size exceeds 30. Therefore, we can confidently proceed with calculating the test statistic. To determine how far the sample mean deviates from the claimed average, we calculate the z-statistic using the following formula. In this case, with a sample mean of 6.5 hours, a population mean of 7 hours, a population standard deviation of 1.2 hours, and a sample size of 50, the z-statistic is -2.95. This indicates that our observed sample mean falls 2.95 standard deviations below the claimed average sleep time of 7 hours. Now, moving on to the third step of the hypothesis test, we need to find the p-value. Assuming the null hypothesis is true, the p-value represents the probability of obtaining a test statistic as extreme as our calculated value of -2.95. This p-value can be found using a z-distribution table by locating the row corresponding to a z-score of -2.9 and the column for 0.05. We found an approximate p-value of 0.0016. This p-value allows us to make a decision about the null hypothesis by comparing it to a predefined value of significance level, which represents the acceptable probability of making a type 1 error. If the p-value is less than alpha, we reject the null hypothesis. Assuming the owner sets a significance level of 0.05, our p-value of 0.0016 is less than this threshold, leading us to reject the null hypothesis. Finally, we conclude our hypothesis test. At a 5% significance level, we have sufficient evidence to reject the null hypothesis and support the coffee shop owner's claim. The data suggests their customers, who consume more coffee, sleep significantly less than the city average of 7 hours per night. This implies a potential link between higher coffee consumption and reduced sleep duration. If you'd like to test your knowledge on this topic, be sure to check the quiz link in the description below or visit our community page. Thanks for watching. Please like, comment, and subscribe for more statistics content.